This is a nuclear battery. It can power spacecraft for hundreds of years with just one charge. How is this possible? Take a copper wire and an iron wire. Connect their ends together. Then heat up one end. Place the other end in a cold environment. A small voltage will be generated between the two materials. Why does this happen? Because the materials we use are conductors. This means there are free electrons inside the conductors. Electrons can move under voltage or potential difference. When free electrons are heated, the vibration of free electrons becomes more intense. By the same principle, when heating a conductor, the heated end of the conductor, the vibration of free electrons also becomes very intense. This pushes electrons to move to the right. This causes fewer and fewer electrons on the left side, creating a potential difference. For the other type of conductor, because metals are different, they will have different numbers of free electrons. When heated, it will also generate a different potential difference. At the same heating temperature, two different conductors will generate two different potential differences. Now we connect the two wires together. The free electrons of both wires will be pushed from left to right. Suppose the upper conductor pushes 20 units of electrons. Then the equivalent number of electrons moving inside will be 10 units. These electrons move in a clockwise direction. This will generate current in the wire. This device is also called a thermocouple. Nuclear batteries are made from hundreds of thermocouples connected in series. Inside it is the radioactive isotope plutonium-238. Plutonium-238 undergoes decay and generates thermal energy. The temperature can reach 932 degrees Fahrenheit. The outside of the nuclear battery faces space. The temperature is below -436 degrees Fahrenheit. This huge temperature difference, when passing through thermocouples, can generate electrical energy and can continuously power spacecraft for hundreds of years. Besides generating electrical energy, conversely, we can also connect a battery between two conductors. Voltage will cause one end of the wire to heat up. The other end will cool down. This is because when electrons transfer from one conductor to another conductor, electrons will transition them from a higher energy state to a lower energy state, thus releasing heat, increasing the temperature at the conductor junction. Similarly, if an electron jumps from a low energy state to a high energy state, it will absorb heat, thus reducing the temperature at the conductor junction. If multiple wires are connected together, a high temperature zone and a low temperature zone will form at both ends of the wire, forming a good heat conductor. Based on this principle, we replace the wires with semiconductor materials. One side is an N-type semiconductor with more electrons through doping. The other side is a P-type semiconductor lacking electrons, forming holes. Now we add a metal conductor block at the bottom of both N-type and P-type semiconductors. At the top, they share one metal conductor block, then connect a power source to the two metal conductor blocks at the bottom. Now let us analyze this system. When electrons pass through the bottom metal, electrons need to pass through high energy level orbits to enter the N-type semiconductor. This process will absorb heat, causing the bottom temperature to decrease. Then when electrons reach the top junction, the situation is exactly opposite. Electrons only need to pass through low energy level orbits to reach the top metal block. This process will release heat, causing the junction temperature to increase. Next, electrons reach the P-type semiconductor junction. Because P-type semiconductors have holes inside, electrons only need to pass through low energy level orbits to enter the P-type semiconductor. This process will still release heat, causing the junction temperature to increase. Next, electrons reach the junction at the bottom position. Because electrons entering the bottom metal block need higher energy levels, so they need to absorb heat. This will cause the bottom junction temperature to decrease, thus forming a heat conductor with low bottom temperature and high top temperature. This type of heat conductor is also called a Peltier. By connecting hundreds or thousands of these Peltier junctions in series, the thermoelectric effect can be maximized. Finally, adding a heat sink creates an effective cooling radiator.